kids and Athena and her boyfriend over for dinner. Hi, everybody. Welcome back to Make the Grade. We had a couple weeks off for spring break and to give you a chance to get back and get ready. And I am back today to start answering some of your questions. If you have never tuned in before, my name is Caroline Richardson, and I am here to answer your homework questions, or if you're confused about a topic, or parents, you're trying to help your son or daughter on something and you're not quite sure in terms of math, you're not quite sure, just give me a call, and I will try to answer those questions for you. The number should pop up on your screen, but if it doesn't, let me give you the number. It's 217-2203. And then throughout the week, if you want, I check the email, and you can email me at mathhelp@wcpss.net. And if you email me questions, I will try to answer them on the air, or I'll get back to you with an immediate answer as soon as I can. All right, so we're going to get started. And actually, we're going to get started today with an email question I had, and the question was, and this is not actually in the curriculum anymore, but it's for extra credit. So this student asked, for extra credit, I have to learn Cramer's rule to solve this system. 3x plus y equals 5, and 2x plus 3y equals 8. All right, and the question was, what the heck is Cramer's rule, and how should I do this? Now, for those of you, now matrices have gone by a little while, but they're starting to review some different information. But if you recall, if you had if you had a system like this with two equations, you could solve it using graphing. And graphing can be ugly unless the solution is pretty, and you're never sure. But sometimes graphing gives you a good estimate. You could solve it by substitution. That's where you take one of the equations, and let's say this first one, and I could solve it for y. I could say y equals negative 3x plus 5, and then everywhere I saw a y in the second equation, I could substitute that value. You could solve using elimination. Elimination is where we would add or subtract the two equations together to try to eliminate one of the variables. Once we eliminate one of the variables, we can solve for the remaining variable and then substitute back to find its solution. And then you learn matrices, where you could actually put this matrix into your calculator, and with a couple different keystrokes, you could solve using the inverse, or you could solve using the RREF button. Several different ways you could have done it using matrices. Well, another method, which is not taught anymore, is called Cramer's rule. So it's probably why it was brought up for extra credit. And if I'm not mistaken, because I touched base with the teacher, if I'm not mistaken, you were asked to solve using all 5 different methods so that you could see that you're going to get the same answer. Okay? All right, well, Cramer's rule is based off, if you have a system, and I'm going to make it a real generic system, ax plus by equals m, and cx plus dy equals, say, n. Okay? So you can see that that's set up exactly the same way. And if you have a system, and again, Cramer's rule is actually using the matrix. You find the determinant of a, b, c, d. Okay? So you're going to find the determinant of the coefficients of your variables. Okay? So be sure that it's set up correctly. Then you're going to find the determinant of the x. Okay? Now, what that will involve will mean that you're going to take the solutions, so m and n, and you will replace them for the values of x in the determinant. So it becomes m, n, b, d. And then they'll find the determinant for y. To do that, you're going to take the m and the n and replace it with the y in the determinant. So it'll be a, c, m, n. Okay? Oops, not a parenthesis. All right, so the key to this, so then your solution will be that x will be the determinant over the, dx over the determinant of the entire system, and y will be the determinant of y over the determinant of the entire system.
That's what I was about to
All right, so how do we do that?
Okay, thanks
Well, you're going to have to remember how to find determinants, which was going back to some of your matrix work, okay?
Bye-bye.
So a determinant, if you recall, was where you would take AD and subtract CB from it, all right? You'd kind of cross multiply and subtract. So let's find the determinant. Now, we also have one other rule, and that is that this will only work if D does not equal 0. Why is that? Right, because you can't have division by 0. So the first thing we need to do is find the determinant of the entire system. So D equals, all right, well, actually, and you know what? I'm not going to do yours. That wouldn't be fair. Let's come up with a sample one, okay? So I'm grabbing another piece of paper. La, la, la. See, you thought I was going to do your extra credit. You almost got me, didn't you? All right. There we go. All right, so let's come up with a sample problem. Let's try 3x plus 2y equals 0, and x minus y equals negative 5. Okay, so I'm going to use this as our sample. So the first thing we need to do is find the determinant. Determinant, I said, was to take a, which is 3, and b, which is 2, and c, which would be 1, and d, which would be negative 1. And to find the determinant, you cross multiply and subtract, right? So it's 3 times negative 1 minus 2 times 1. 3 times negative 1 is negative 3, minus 2 times 1 is 2, so that would be negative 5. So D is equal to negative 5. Since it is not equal to 0, then this is going to be a valid solution. So now we find dx. And sometimes what we like to do is you kind of cover up the x's with your thumb or one of your fingers and then take the solutions and put them there. So it'll be 0 and negative 5 going for your x's now, and the 2 and negative 1 remain for your y's. So again, what do? We cross multiply, so 0 times negative 1 minus negative 5 times 2. That would be 0 minus a negative 10, which becomes positive 10, so dx is positive 10. Finally, we find dy. Again, what do? We're going to cover up our y variables, and we're going to put our solutions, 0 and negative 5, in for the y. So our x will stay the same this time, 3 and 1, and then we'll put in 0 and negative 5. All right, to find the determinant, what do? You cross multiply. 3 times negative 5 minus 1 times 0. 3 times negative 5 is negative 15, minus 0 is negative 15. Then we said that the solution, the actual solution for x, is dx divided by d, which is the determinant using the solutions in for x, and the determinant of the entire system. So that would be 10 divided by negative 5, which makes x negative 2. And y, at this point you could go back and substitute, but we'll solve the whole thing using Cramer's rule. Would be dy divided by d, so the determinant with y and the determinant of the system, which would be negative 15 divided by negative 5, which is positive 3. So your solution is negative 2, positive 3. And you certainly can go back and check. We could check this on the calculator using the matrices. We could use elimination. We could use substitution. And if I'm not mistaken, and you better double check the way your extra credit was asked, you were asked to do all 5 different methods: graphing, substitution, elimination, matrix, and Cramer's rule. So it wasn't just solving by Cramer's rule. It is just one other way to do it, okay? All right, well, I hope that helps you out. And once again, if you guys have questions, you can email them or just call in, okay? All right, well, I heard the phone ring, so let's see what we have. We're getting there. Okay, so Little Bird told me that you guys were also working on factoring Algebra 1. It's not going to go away. You need to practice, 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 okay? So what I wanted to do, until we start getting some calls, is to go ahead and review some factoring problems. Now, geometry, this is not going to hurt you because you're getting a little bit deeper into things now. And as you get a little bit deeper into this, it's going to be a reasonable question for your teachers to go back and ask you questions that involve factoring. You're supposed to remember your Algebra 1. Algebra 2, factoring is becoming more and more critical as you start learning what are you in radical expressions and equations now. As you start learning more and more, you're going to need to start expanding. You have to, again, remember your Algebra 1 factoring. All right, so it's not going away. All right, so let's look at these 2 sample problems. First one says, solve x squared minus 8x minus 48 equals 0. Let me zoom in just a little bit so you guys can see that. Woo! There it goes. It always shocks me when it starts going fast. Okay. So solve x squared minus 8x minus 48 equals 0 by factoring, okay? Don't get worried about this equals 0. You don't want to lose it, but you don't have to worry about it until the very end. So let me cover it up for just a second and ask you, how would you factor this problem right here? Now this one, when there's not a number in front of the x squared, when it's just, well, there is a number there, right? It's a 1. When the number's a 1, sometimes it's much faster to do really what's a guess and check. Open up your parentheses, throw that equals 0 in there, and factoring. Factoring, you're trying to find two numbers that multiply together to give you that answer, right? All right, so the one thing you have to remember is that there are numbers that have to multiply to give you 48, but add up to give you negative 8. Multiply to give you a negative and add up to give you a negative. So would the signs be positive, positive? No. Would the, oops, you can't see that. Would the signs be negative, negative? No. Are the signs going to be a positive and a negative? Yes, that's the only way we're going to be able to get that to work, okay? All right, so if we factor our x, and x, that one breaks up pretty easy. And now what are numbers that multiply to give you 48 but add up to give you 8? All right, well, let's look at numbers that multiply to give us 48. 1 and 48. No combination of 1 and 48 are going to give you negative 8, okay? 2 and 24. 2 times 24, okay, but if you took 24 minus 2, you're going to get 20. And if you take 24 plus 2, you get 26. So that's not going to work. So 3, does 3 go into it? Divide into it, 3 goes into 4 one time with, so 19. 3 and 19, so 19 plus 3, 21, 22, no, that doesn't work. And 19 minus 3 would be, nope, 16, that doesn't work. All right, 4 times 12. 4 times 12. 4 plus 12 will give us 16, but 12 minus 4 will give us 8. So there's our possibility right there, okay? So now the question is, we know that our factors are going to be 4 and 12, so now we need to decide on the signs. The final answer has to be negative 8. So if it's negative 8, how would that work if you have the number of 12 and the number 4? Well, it would have to be negative 12 with positive 4. And test it. Negative 12 plus positive 4 equals, yep, negative 8. And that's what you wanted. And does negative 12 times positive 4 give you negative 48? It sure does. As long as both of those worked, you're good. All right, so now we've factored, and that's kind of a quickie. Whenever there's not a number right here in front of, or when there's just a 1, I should say that. When there's a 1 in front of the x squared. I'm going to show you another method by grouping when there is not a 1 in front of the x squared. All right, but now we have to deal with this equals 0. There's a fundamental rule out there that says if two numbers, we'll say a and b, multiply to give you 0, then either a equals 0 or b equals 0. So when we're solving these, we solve for both cases. So x plus 4 equals 0, and x minus 12 equals 0. Solve for both cases. And you would be smart to break it up just like that. Don't just do it in your head. So subtract 4 from both sides. We're left with x equals negative 4, and add 12 to both sides. We're left with x equals 12. So the two possible solutions are x equals negative 4 and x equals 12. And now that you've been, as you start to working with this, remember, these are representing where it hits the x-axis. So if you were to graph this real quickly, you could graph it at negative 4 and 12, and somehow your parabola might be going like this. It's kind of a rough guess. But it'll give you a feel for what the graph looks like, okay? All right, let's look at the next one. Solve 2x squared minus 5x equals 88 by factoring. All right, first of all, you have to get it in the proper form. The form of a quadratic is ax squared plus bx plus c equals 0, okay? So what's preventing us having it in this form right now? Well, that 88. So we need to subtract 88 from both sides. If you're ever left with an equation, in geometry this will hit you especially, if you're ever left with an equation that has an x squared, has that quadratic, look at me a second, it has that quadratic and there's an x squared, and all of a sudden that x squared, you can't eliminate it, there's not not an x squared on both sides of the equation, that's when you're going to have to bring everything over to one side, set it equal to 0, and start doing the factoring. Now geometry, one of the things you'll need to be careful of is if your solution, let's say you're solving for x and x represented the length of a side. In our last problem, if x represented the length of a side and it came up with x equals negative 4, that would be impossible. So there's going to be times where you need to actually look at the answers, not just to check them to see if they're correct, but are they actually valid for the type of question you were asking. Okay? All right, so let's go back to this one. So we're going to subtract 88 from both sides. That'll leave us with 2x squared minus 5x plus 88 equals 0. Okay? Now, this one I would do by grouping as well. You can try to do guess and check, and sometimes when the numbers are in front of, the number in front of the x squared is not too big, you can try a guess and check. So if we were to open this up, open up our two parentheses, we know that the only factors of 2 are 1 and 2. Okay? But we still have to get to the situation where it's going to multiply, these last terms are going to multiply to give you 88, but add up to give you negative 5. But then you have to throw the 2 in there. So it does get a little bit complicated. So doing it this way, we're going to have to start guessing and checking. We have numbers that multiply to give us 88. So it would be 1 and 88, 2 and 44, 8 and 11. Okay? But then we have to put those with combinations of the 2. So you have to start testing everything. So you could say, let me grab another piece of paper again, because I'm going to test and then take it away. So what if I put 1x and 2x, there we go. What if I put the minus 2 and minus 44, because a minus times a minus has to give us positive 88. Well, then you're going to have to very quickly go back and say, okay, x times x, that's 2x squared. X times negative 44 would be negative 44x. Negative 2 times 2x would be, negative 4x. And then last would be negative 2 times negative 44, which would be positive 88. So when you go back and refoil it, do your center terms give you what you want, which in this case was 5. No, they don't. Okay? So you need to try another combination. This is why when the next method I'm going to show you, which is solving by grouping, is going to make your life a lot easier because you don't have to test each time. Okay? So let's try this one. Let's try x minus 8 and 2x was the other factor plus 11. Let's try that. Oops. So it's going to have to be plus 8, right? So 8 times 11, that gives us the positive 80. Well, we have to go back and factor. X times 2x would be 2x squared. Good. X times 11 would be 11x. Oh, no, I do have to have that negative in there, don't I? So then negative times 2x would be negative 16x. And then negative times 11. What did I do? Oh, I ended up supposed to have a minus there. Equals minus 88, so that works. So do 11x minus 16x, does that add up to negative 5x? It does, it does. So we found the answer, okay? So our factors here are negative 8 and 2x plus 11. All right, that took an awful lot of time to do guess and check, doesn't it? So we're going to have to find a better method, and we will. But now that we have our two factors, now what do? We set them equal to 0. So x minus 8 equals 0, and 2x plus 11 equals 0. Break them up, okay? Write it down. Add 8 to both sides, x equals 8, and subtract 11 from both sides, 2x equals negative 11, so x equals negative 11 halves. So your two possible solutions are 8 and negative 11. Now, one of the things that I haven't shown you is that you really, really should, once you find a solution, you should go back and substitute those values back into the equation to be sure that they work. Okay? And remember, what do those represent? Those represent where the parabola, because that's what a quadratic graph's to be, where the parabola touches that x-axis, okay? So it's just another way for you to check your work. All right, I hope that helps out. All right, we have a call in from Diane from Eastwake High School in Algebra 2. And Diane has asked us to solve for x, giving radical x minus 4 equals x minus 8, okay, or square root. So the first rule when you're solving for a radical is you want to try to isolate the square root on both sides. We have. This problem already came with the square root on one side all by itself. So then the next thing we need to do is try to figure out a way to solve for that x. Well, one of these x's is kind of hidden in the house and up underneath the radical, isn't it? So what are we going to do? Well, what is the only way, and this is not proper math, but what's the only way to get rid of a radical? Okay? Well, think about it. Square root of x times the square root of x equals x. You multiply it times itself. Well, what's another way of calling that? Square root of x squared is x, okay? So, remembering that rule, we need to try to eliminate this radical. So what we'll do is we'll square both sides. The glory of algebra, look at me, the glory of algebra is that you can do anything you want as long as you do it on both sides, right? You could add 27 to both sides. You could divide by negative 3.7511 on both sides. You can do whatever you want as long as you do it to both sides. Now, are there things that are better to do than others? Yes, I'm not quite sure why you'd want to subtract 27 on both sides unless there was a 27 in the problem, but you get the idea, okay? So in looking at this one, we have a radical. So what do we want to do? We're going to square both sides. All right, so then when you square a square root, the family underneath, you're left with x minus 4 equals x squared minus 64, right? No, 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 bad, bad, bad. This is a classic trick that you fall into because you get so used to just that radical disappearing. You need to remember what this means, okay? This is wrong. It becomes x minus 4 equals x minus 8 squared. Well, what does x minus 8 squared? You can't give that 2 to the x and the 8 as long as you've got that negative sign there. What does it mean? It means x minus 8 times x minus 8. Yes, you're going to have to FOIL that or do the box or whatever method works for you. So x minus 4 equals x times x is x squared. X times negative 8 is negative 8x. Negative 8 times x is negative 8x. And negative 8 times negative 8 is positive 64. Now, you should know how to very quickly, this is a quick pattern you should learn, that, hold on, let me write it out, that when you have a binomial and square it, it's basically square the first term, square the last term, multiply the two together times 2. See? All right, it's a nice pattern to learn. All right, well, we're still not done, right? We still have to solve for x. So what did I say before? I said look to see you have an x squared, but there's no other x squared that's going to cancel it out. So what does that mean we're going to have to do? Factor. We're going to have to factor this. To do that, we're going to have to set everything equal to 0 and put it in the correct form. All right, so let's subtract x from both sides, or add a negative x to both sides. That leaves us with x squared minus 17x plus 64 equals negative 4. Now we're going to add 4 to both sides. So we're left with 0 equals x squared minus 17x plus 68. Okay? How are we going to factor this? Well, here's one with a there's a 1 in front of the x squared. So we know we can split up the x. Now what do we do with the 68? Well, we need two numbers that multiply to give you 68, but add up to give you negative 17. What are numbers that multiply to give you 68? 1 and 68, 2 and 34, right? You just go through all the different factors. What else? 3 doesn't go into it. 4 going to 68. 4, does it? 68 divided by 4 is, yep, 17. All right. So do those, none of those so far are multiplying to get it. Does 8 go into it? No, it doesn't do that. Nope. So I think that's it, actually. So what we have found is that none of these combinations right here are going to add up to give us negative 17. So now what? Well, you can complete the square, or there's another technique that I bet your teachers are teaching you, even though it's not, Algebra 1, it's not in your curriculum. Algebra 2, it's definitely in yours. But you know what? It's a really handy tool. So I bet a lot of your teachers are teaching it, and it's called the quadratic formula. You heard the quadratic formula? Come here, look at me. Quadratic formula. Quadratic formula is a method where you're going to be using the coefficients of the quadratic, the equation that you have. You're going to be using those coefficients to solve. So you won't be worrying about your x squared and your x. I will tell you, however, that the quadratic formula sometimes can cause you stress in that you have to deal with the negatives, okay? You have to be very, very careful with your arithmetic. And you get so caught up that you're solving an algebra problem with a quadratic and doing this high-level math that you think, oh, well, this is just arithmetic, and it's very trivial, and you don't pay attention. Be very, very careful, okay? Now, what is the quadratic formula? I learned the quadratic formula by singing Frère Jacques to it. So I'm going to sing, even though my voice is a little hoarse. Wait, let me take a quick sip of water. Oh, did you notice I have an Applebee's cup? There we go. Somewhere in there. There you go. And the reason why is because every time you call in, Applebee's is giving you all a free milkshake or dessert. So call in with your questions. All right, so ready? La la la. Negative b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Okay, don't turn the channel. I won't sing it again. Yes, I will. All right, come down here to the paper. So, quadratic formula. Negative b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a, okay? And there's the quadratic formula. And where are these a, b's, and c's? Well, they're coming from the general form, or the standard form of a quadratic, which is ax squared plus bx plus c equals 0. So what I'd strongly recommend to you is that here's our recipe, the quadratic, or the standard, let's put that out again, the standard form of a quadratic. There's our equation. Here's our recipe, which is the quadratic formula. So let's write our, I'm going to bring it down here so we can see it. So 1x squared minus 17x plus 68 equals 0. Let's get our ingredients straight. A equals 1, b equals negative 17, and c equals 68. Get your ingredients straight so you don't have to keep running back and forth. If you were making cookies, would you just keep running back and forth to the pantry? Well, you might, but you shouldn't, okay? So we get everything out on the counter ready to go. So here's our ingredients. So now we start substituting in. Now, I said negative b, but sometimes you really need to think of this as the opposite of whatever b is. So the opposite of negative 17. Don't do the math, just put in the values, substitute in the values. Plus or minus, where's that coming from? Because you need to have two solutions. B squared, so negative 17 squared, minus 4 times a, which is 1, times c, which is 68, all over 2 times 1. Okay? So now you've substituted in your values. Definitely use your calculator if you want to. I would do little parts at a time. Because the reason why is later on you're going to learn that, or if you haven't already, is that if we cover up this part, this opposite of negative 17 over 2, that's the negative b over 2a, this part right here. That's going to help you find the vertex of your parabola. And then the value underneath, this b squared minus 4ac part, that's going to help you determine what type of solutions or roots you have. All right, so negative 17, so minus and minus 17 becomes 17, plus or minus the square root of negative 17 squared becomes 289, minus 4 times 1 times 68 is 272, all divided by 2 times 1, which is 2. So 17 plus or minus 289 minus 217, or 272 is 17, all divided by 2. So that's it. Those are your two solutions. The 17 doesn't simplify. So you could say my two solutions are 17 plus square root of 17 divided by 2, and 17 minus the square root of 17 divided by 2, which if you substitute into your calculator, you would get an approximation. Why? Because 7 is square root of 17 is an irrational number, right? So you'd get a very long decimal, which, depending on your case that you're working with, that might be enough for you to have. You know, you might round it out to the nearest thousandth, and that might be enough. But mathematicians have no problem with writing it together, this plus or minus piece together. Okay? All right. Diane, I hope that helps. If you have any other questions, just give me a call, and I will answer them, okay? All right, so good luck with that one. All right, is there another question? All right. Melissa from Nightdale says, a geometry question, says Dana buys property that measures 20 yards squared. Will she be able to completely cover a rectangular floor that measures 12 feet 6 inches by 16 feet 6 inches? Explain why or why not. Whew, you're going to challenge me on this one to think real quick, aren't you? All right, Melissa. Well, looking at this, we have an issue going on here with units is one of my guesses that we need to deal with. So what I would do, the first thing I would do is I would change my yards into feet squared so that I can deal better with the feet and inches going on. So let me think. Gosh, you got me. So let's remember, we know that 1 yard squared equals 3 feet, right, times 3 feet, which equals 9 feet squared. Okay, so there's our conversion. So if we have 20 yards squared, 20 yards squared would equal 20 times the 9 feet squared, which will give us a total of 180 feet squared. Okay, so that's this number converted so that we can deal with it a little bit prettier. Okay. The next thing is we need to look at, will it be able to completely cover a rectangular floor that measures 12 foot 6 inches by 6 feet, or 16 feet 6 inches. So if we do that, 12 feet 6 inches, we have to put that all in one common unit. So I've converted to feet, so let's keep this at feet. So that would be the floor is 12 and a half feet by 16 and a half feet. And where's that half coming from? Well, 6 inches is half a foot. All right, so if we were to find out the approximate area of that, area of a rectangular shape is basically base times height, or in this case you could say length times width. So base times height, so it would be 16.5 times 12.5, which gives us 206.25 feet squared. All right, so the question is now, does 20 yards squared, or 180 feet squared, work for a floor that's going to need a total of 206.25 feet squared worth of materials? Well, the answer is no. At this rate, you're only going to be able to cover a portion of it, and you'll have a section left over. You won't have enough, what was it, well, whatever the material is to do this. She wouldn't have enough to get us there. She'd be off by, if we go ahead and subtract those, 206.25 feet squared minus 180, feet squared, 206.25 minus 180 equals 26.25. She'd still have 26.25 feet squared left in the room to cover. Okay? Great question. That took me a while to think about it, to think it through. And the reason why, and I'll tell you what, the flag went up, the first flag that went up was when I started noticing the different units. Okay? On the EOC, they love to do this. They don't put units out there very often on the EOC, but when they do, Melissa, what they're looking for you is to make some conversions. Okay? And then this conversion right here, you've got to be careful because we know that 1 yard equals 3 feet, but the question, you got to be real careful because that was yard squared. That's why I had to step back a second and look at that. 1 yard squared is the same as 3 feet times 3 feet, which is 9 feet squared. So that's really your conversion. It gets very tricky. Okay? All right, Melissa, great question. Thank you so much. I hope that helps. So if you have any other questions, just give me a call. Okay? All right, thank you. All right, Algebra 2. Let's look at a few more radical type problems. Because they're good. We like them. All right, let's look at this first one. First rule, oops, let's see. Can you see it? There we go. First rule is you need to be sure. There we go, sorry. Try to straighten it out. You want to be sure that you've isolated the radical, okay? What do I mean by isolating the radical? I mean getting the radical alone on a side by itself, kind of like when you isolate x on one side. So let's subtract 2 from both sides. So we're left with the square root of 3x minus 2 equals 6 minus 2, which is 4. Okay? Now what do? Remember we said that square root of a squared is a. So to get rid of or eliminate that radical, we will square both sides. Okay. So we're left with 3x minus 2 equals 4 squared, which is 16. Okay? So the next thing we want to do is add 2 to both sides. So 3x equals, if we add 2 to both sides, 18. Now we're going to divide both sides by 3. You know what? I got to back up here. No, I'm good. Okay. Divide both sides by 3, and I'm left with x equals 18 thirds. You know what? 18 thirds is a good answer. No, it's not. We can reduce that to be 6. Yeah, you don't want to leave the simple ones, okay? All right, so 18 thirds equals 6. So the value of x that makes this work. Now, you always should check your radicals, especially when you're doing things on both sides. If there happens to be a radical on both sides, You better check, because at least 50% of the time, just like when there's an absolute value on both sides, say about 50% of the time, one of those answers will not work, okay? So you're going to want to go back. All right, let's look at part B. All right, well, you said, I thought we were doing radicals. Hello, look at this. It's 2/3. You're learning now that fractional exponents are really just square roots, right? Or square roots were really hidden fractional exponents. But you know what? We don't have to convert this back to a radical. If you converted this back to a radical, you would have the square root. Oh, no, you wouldn't. What would you have? You'd have the cube root of 2 times x minus 2 squared. That's ugly, okay? You don't want to go back to that. You don't have to. What we need to do is isolate the 2/3, which is being applied just to this parenthesis, okay? So let's divide everything by 2. So we're left with x minus 2 raised to the 2/3 power equals 25. All right, so now what? How do we solve this? Well, think about your exponent rules. If I had a to the x power raised to the m, wouldn't that be a to the x times m? Yes. When you raise a power to a power, you multiply. Well, can you think of any number that if I multiplied it by 2/3, it would disappear, if you will, and it wouldn't be an issue for us anymore? Sure. What if I multiplied it by 3/2? Those would cancel, and I'd be left with 1, which is what we need. We need an exponent of 1 so that we can solve for x. So let's raise both sides. Remember, just like I did the square root of both sides, now I'm going to raise both sides to the 3/2 power. Can you do that? Sure, you can do that. You can do whatever you want as long as you do it to both sides, okay? All right, so I have chosen to raise both of the sides of this equation to the 3/2 power. Well, 2/3 times 3/2, right? Power to a power, you multiply, will leave me with that x minus 2. And then 25 to the 3/2 power. You can type that into your calculator. What that really means is the square root of 25 cubed. So let's just go ahead and pop that into the calculator. So if we look at our calculator, we'll take 25 raised, use that little caret symbol, and I would use parentheses to indicate that you're putting a fraction. 3 divided by 2, which is the 3/2, equals 125, okay? Which equals 125. And now you've simplified it to a point that you can deal with it, okay? So there's one other little catch in there, though. Since we have raised it to the 3/2 power, remember I just said that this is really equivalent to taking the square root of 25 cubed. Well, when we're taking the square root of both sides, which is basically what we have done, you have to end up your answer. You have to end up say, let me do something simpler. The square root of a is plus, square root of a squared is plus or minus a. Okay, so if I ask you what is the square root of 9 in an equation using radicals, you would say plus or minus 3 to deal with both solutions. All right, so in this case, we'd have to say it equals, let me break it over here, x minus 2 equals negative 125, and x minus 2 equals positive 125. Remember, that kind of looks like the quadratic formula where you had plus and minus. All right, so now add 2 to both sides. We're left with x equals plus 2, negative 123. And we add 2 to both sides here. We're left with x equals 127. 2 possible solutions. Again, I would go back and test those to be sure that they are valid. Okay? Good problem. This is a great trick problem and a great problem for a teacher to put on a test. I don't want to say that they're trying to trick you, but what they're looking for is that you recognize that when that denominator, when you've raised something to a denominator of 2, that you're taking a square root. And whenever you take the square root, you're going to have to deal with both solutions. All right. So let's look at this last example. Square root of negative 3 plus 5, and that plus 5 is not under the radical, equals x. All right, now this one can get tricky because you have to notice that you've got the x on both sides. This would be one of those cases that at the very end, I would be sure I checked both my answers, because there always is a chance when you have a variable on both sides, or you have, like I said, the absolute value on both sides. I'm just going to rewrite this on a different piece of paper. That those solutions, both of those solutions might not work. Plus 5 equals x. So since I have an x on the inside of the radical and the outside of the radical, we want to be really, really careful. And whoop, there it is on the screen. Sorry about that. All right, I have to look up once in a while to be sure that y'all can see what I'm talking about. All right, so First thing we need to do, isolate that square root. Don't worry about the fact that there's an x on both sides. We'll deal with that later. So what do we do? Subtract 5 from both sides. So the square root of x minus 3 equals x minus 5. Now, how do we eliminate a square root? Well, we square both sides. See, there's that sucker question happening again. So that leaves us with x minus 3 equals x minus 5 squared, which is x minus 5 times x minus 5. You have to expand it. So good. So x minus 3, now what do we have to do? Do the FOIL method or box, whatever works for you. So x squared, x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is positive 25. So we're left with x minus 3 equals x squared minus, 10x plus 25. All right. And remember the pattern. We said if we had how do I want to say this to you? Oh, if I have this x minus 5 squared, it's a binomial squared, so what do? We say square the first term, there's x squared, square the last term, positive 25, multiply the 2 together, which is negative 5, times 2, which is negative 10. All right. All right, so now we're down to the point where we have an x squared on both sides. That does not eliminate, right? There's not an x squared on both sides, so what do? We're going to have to factor. So to factor, what do we have to do? We're going to have to bring everything over to one side and set it equal to 0. All right, so let's do that. Let's subtract x from both sides, or add a negative x to both sides, however you want to look at it. Whenever I have a negative, it always looks better if I add a negative to both sides. And we have to add 3 to both sides. Okay, there we go. So we're left with 0 equals x squared, a negative 10x plus a negative 1 would be negative 11x. And 25 plus 3 would be plus 28. All right, so how are we going to do this? How are we going to solve this? Well, you try to factor it. There's the 1, the leading, or the a, if you will. When I say a, ax squared plus bx plus c equals 0, right? This a, the leading coefficient of the x squared, the quadratic, is a 1. So this might be a simple one to factor. Remember the rule. The rule is it has to multiply to give you 28, but add up to give you negative 11. What are numbers that multiply to give you 28? 1 and 28, 2 and 14, 3 doesn't go into it, 4 and 7, 5, that looks like it's it. All right, so of these factors, do any of these work out to give us 11? 1 plus 28 doesn't work. 14 minus 2, that's close. That's 12, but here it is, 7 and 4. If you take 7 plus 4, you get, or negative 7, there we go, and negative 4, you get negative 11. Good. All right, so there's our answer. But how do we get the positive 28? Well, don't panic. Negative 7 times negative 4 is positive 28. They both check, so there we go. And you better check them because those signs can sometimes trick you. So what did I say? My values are going to be negative 7 and negative 4. All right? So now what? We have it equal to 0, so that means we're going to have to create 2 separate problems. X minus 7 equals 0, and x minus 4 equals 0. Add 7 to both sides. X equals 7. Add 4 to both sides. X equals 4. Now in this one I said I would always strongly recommend that if you have a radical on both sides, or in this case we had a variable on both sides, I would go back and check my answers just in case. All right? So let's take our original problem, which was the square root. Let me bring it down. Hold on. Keep doing that to you. There we go. Square root of x minus 3 plus 5 equals x. And substitute in our values, x equals 7 and x equals 4. So does the square root of 7 minus 3 plus 5 equal x, which was 7? And does the square root of 4 minus 3 plus 5 equal 4? Do those cases work? All right, let's test it. 7 minus 4 would be 4, so the square root of 4 plus 5, does that equal 7? The square root of 4 is 2. 2 plus 5, does that equal 7? Yes, it does. 4 minus 1, or 4 minus 3 is 1, so the square root of 1 plus 5, does that equal 4? The square root of 1 is 1, so 1 plus 5, Does that equal 4? That's 6 equals 4. Huh? Zoom out? To zoom out. Is that better? See, I'm getting too caught up in my problem here. You know why? Because I'm trying to be sure that I didn't make a typo here, but 1 plus 5 equals 6. 6 does not equal 4, so that's telling me that x equals 4 is not a solution. If I did my arithmetic right. Did I miss? Oh my gosh, look at your screen. I don't know what happened. Here, let's try this button. Is that better? Or am I upside down? Keep going. Just want to be sure you're watching out there, ladies and gentlemen. There's all kinds of buttons down here on, this is called an Elmo. Elmo like this. There's all kinds of buttons down here, and if you hit the wrong one, obviously, you just flipped the whole problem over, didn't it? All right, so words to remember now is that when you have the variable on both sides, or a radical on both sides, or an absolute value on both sides, especially that variable on both sides, always, 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 there's only one problem where you check your solution, check those, okay? All right. Good job. Keep working with those radicals. Allie from Southeast Raleigh High School. Factor completely. We love to factor. We love to factor. Why? Because it's never going away. It's not going away when you continue on with all your math. It may go away if you decide not to do math and do something else, but somewhere along the line, factoring will come back. All right. So how do we factor completely? All right, well, looking at problem A, which is right here on the screen, Allie, you have 9x squared plus 5x minus 6. And do you remember a second ago I said, if you wanted, let me take a quick sip of water. If you wanted, you could start doing some guess and check, okay? And if we started guessing and checking on this one, we'd have to take the factors of 9, which are 1 and 9 and 3 and 3, together with the factors of 6, which are 1 and 6 and 2 and 3, and we would have to find the method of 1x and 9x, is that 1 and 6, and go back and refoil. Does that work? And you'd have to test each and every combination. Now you're saying, oh, that won't take so long. Well, you know what? It does take a long time. It's very tedious, and you have to be sure that your foiling correctly each time. It becomes very tedious. So there is a method out there that you can always get it right, okay? And that's factoring by grouping. And sometimes I call it the AC plus B method, okay? Now, where's that A, C, and B coming from again? AX squared plus BX plus C, okay? That's standard form, which is what this is in. So the rule is you multiply the first term and the last term together. What's 9 times negative 6? 9 times negative 6 is negative 54, okay? And then what's the B term? The B term is 15, okay? So the question is, oh my gosh, Allie, you know what I've done? Look how big these numbers are. You know what would have made my life a lot easier? GCF. Oh, how could I even forget that? Where's my head today? When you're doing factoring, always, always, always try GCF first. Now, the way I'm going, I'll still get the right answer, but my factors will turn out too big and I'll have to factor out again. Okay, so I'm glad I caught myself in that. Kept looking at 9, 15, and negative 6, thinking there's got to be something in common. Well, what do they all have in common? They have a 3 in common. So that leaves us with 3x squared, 15x, that would leave us with 5x, 5x, and 3 divided into negative 6 would leave us with negative 2. Much more workable numbers. Okay, let's do that. We still could have done it the other way. Don't panic if you missed it like I did there for a second and then you remembered it. You can still get the right answer. It's just that your value is a little bit bigger. All right, so we're still going to do the same thing. Take the 3 times the negative 2, which leaves us with negative 6, and then the B term is 5. Can you think of two numbers that multiply to give you negative 6, but add up to give you 5? Well, 1 and 6. 6 minus 1 is going to give you 5, okay? So we need positive 6 and negative 1. Let's test that. Positive 6 plus negative 1 is 5. Positive 6 times negative 1 is negative 6, so there's our number. Now this is the fun part about the grouping. What you're going to do is you are going to take the center term, 5x, and you're going to use these two factors, okay? And you're going to break up the term. Now don't lose your 3. The 3 kind of has to carry down here to the end of the problem. So what are we going to do? We're going to say 3x squared minus 1x plus 6x minus 2. Now, we have not changed the problem, okay? This would be, if we had started with this, all we would have done is taken negative x plus 6x and simplified it to be the 5x. And you've seen this before. When you FOIL, you see this, right? All right, so we're just kind of going backwards, and we're kind of unfoiling, okay? All right, the next step is that you would group the first two and group the last two. Then you're going to find the GCF of each one of those. Now, even if it's a 1. So what do 3x squared minus x have in common? Well, they have that x. So we'll factor out the x, and we're left with 3x minus 1. Plus, what do 6x minus 2 have in common? They have a minus 2 in common. Positive 2 in common. So 6x divided out 2 would give us 3x, and 2 divided by 2 gives us minus 1. Look at that. You see those groupings? All right, so they both have a grouping of 3x minus 1 in common. So you factor out the group that they have in common. So let me come up here. So we have the 3, which I brought down. All right, I'm going to factor out the grouping. So I'm going to factor out the 3x minus 1, and what am I left with? Well, I'm left with x and a positive plus 2, and that is your other factor, x plus 2. Now, that took me a few seconds to talk about it, but once you master this, this is going to make your factoring life so much easier, okay? And the best way to practice this, I hate to say this, is to practice, 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 practice. It's going to be the best way for you to learn this. Not the best way to practice it, duh. Okay? The best way for you to learn this, it has to become natural. It has to be one of those things that you look at the problem, you're like, oh, AC plus B method. I can do it. I can do it. Factor by grouping. Factor by grouping. Okay? All right, let's look at problem B. Problem B. Ha, you're not going to trick me this time. Problem B. I'm getting bored with blue. I'm going to change to purple. Let's find, the first thing, notice, they're all even. Definitely has a GCF. GCF could be 2. Let's look bigger. 4. 4 is definitely a GCF. We have an awful lot of variables in here, so let's see. We have an s to the 4, s to the 3, s to the 2. So they all have s to the 2 in common, so we can factor that out. T to the 1, t to the 1, t to the 1, so we can factor out a t as well. Okay? And when we factor it out, sometimes it's easy for you to think 4s squared t times what gives me 12s to the 4t? It's one way of looking at it. So that leaves you with 3s squared plus 4 times 5 would give me the 20. S squared times a single s would give me s cubed, and t times t, minus 4 times 2 would give me 8. S squared taken care of, t taken care of, done. All right, so now what do we have? Well, this 4s squared, don't lose it, okay? And sometimes I tell my kids, put a ring of fire around it so that you remember this is something that has to be in the final answer, okay? Now, if you're being a good little mathematician, you're going to bring that down all the way. But I know what happens sometimes. We just draw an arrow. That's very lazy, but you can do it as long as you remember that you bring it down to the final part, okay? Now, if your teacher wants you to write each step, please do that. I'm probably shortcutting you just because I have watching my time tonight. All right, so how are we going to factor this? All right, AC plus B. What's A times C? What's the first term times the last term? Negative 6. Oh, look, it's going to do it again. This doesn't always work out to be negative 6 and 5, by the way. And then the middle term, the B term, was 5. We already know, we found a second ago, that the numbers that multiply to give us negative 6 but add up to give us 5 are plus 6 and a minus 1. Okay? All right, see, notice this time I switched them because I wanted to show you that it's okay if you do that. All right, so I'm going to split up that 5s. So I'm left with 3s squared plus 6x minus 1 minus 1x minus 2. Okay? Then I said group the first two and the last two. All right. You cannot, 3s squared plus 6x, you can put the parentheses there, but you cannot just put a parenthesis in front of that negative sign. Otherwise, you lose the negative that belongs to the x. And if we put a parenthesis right here, that implies that that negative would be distributed to the x and to the negative 2. So I'm going to change this to plus a negative x just to make my life a little bit easier. And now I can see it. Good. All right, then what do? We GCF, both of them. What do 3s squared and 6x? I lost my variable, s. You guys are probably like, where did the x come from? Don't panic, Ellie. And you can do that at the very beginning of an equation. If you want to change your variables, you just have to change them back. It's called substitution. All right, so they both have a 3s in common. That leaves me with S plus 2 plus, now what do negative S and a negative 2 have in common? Well, I'll give you a hint. Anytime that leading number or variable in the grouping is a negative, you're going to be factoring out a negative something. So in this case, a negative 1. That's what they both have in common. So that leaves us with S plus 2. Ah, wonderful. Look at this. The groups match. That's what you want. If we hadn't factored out the negative 1, our signs would have been off slightly, and that would have been a heads up to you. All right, so what do? We're going to factor out the grouping, S plus 2. And then I always put my fingers over it. Whatever's left is the other grouping. 3S plus negative 1. So the other grouping is 3S minus 1. And I'm all done, right? No, remember our ring of fire? I've got to bring that down. 4S squared T. That's entirely factored. Great problem. All right, Allie, I hope that helps. All right, I think we have time for one more. All right, a call came in from Southeast Raleigh for a geometry student, but we're not quite sure what your name was, so let's just look at this one. Use a matrices to find an image of triangle SUD under the translation vector 4, negative 5. Ordered pairs for SUD are S, U, and D. All right, so let's go ahead and plot this and then analyze the problem just a little bit, okay? Oh, we're going to use matrices, so we don't even really have to plot it, but let's get an image of it anyway so you can see what's going on. I hope I gave myself enough room. All right, so S is negative 1, negative 1, negative 1, negative 1. There's S. V, or SUD, hello. U is 2, negative 5, so 1, 2, 1, 2, 3, 4, 5. There's U. And D is 3, 2. 1, 2, 3, 1, 2. There's D. Okay? You should never freehand this. You should never freehand this. So what am I doing? Freehanding this just because of our time. Okay? All right, so now what are we going to do? We are going to, under the translation vector, translation means it's a slide. Okay? So we're going to slide this. What are we going to slide it? We're going to slide it 4, negative 5. Well, what does that mean? The translation vector, if we were to plot 4, negative 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. And I was to draw an arrow from the origin to that point, okay? That amount of distance. Now what I don't have, I have somewhere, but I don't have it right here in front of me, is my overhead and my patty paper. Hold on a second. Oh, time out. No, I don't have it. I have it somewhere, and I'll be sure I'll bring it next time. But if I was to, I don't think we can see it if I do it, but I'll try. If I was to take our original, and this will be not the way we should do it, I will bring my patty paper next time, okay? And underneath it, let me darken it up. This is what's really happening. What's really happening is we are going to move along that vector. We're going to move this, take this little point, we'll call it a little bug, and we're going to move it to the end of that vector. So you're taking your original picture, hold on, make it as small as you can so you can see it moving. See, who says we can't be creative? All right, there we go. So here's our original picture, right there it is. And we're going to drag it along that vector. Boom. Okay? So that's where our new image is going to be. All right? So that's what it means when it says a translation vector. If you were to draw that or plot that point and from the origin draw an arrow, a vector, and a vector is very similar to an array. It shows direction, and in this case now it shows magnitude, a distance, right? You could actually find the distance of that. And that's what just happened. All right, so if we were to physically do it, if we were to physically do the translation, that's what we would do. Well, so here we know about where our coordinates are, and if I had a piece of tape, I'd tape that down so we could see it. But we want to solve this using the matrix, okay? So what does that mean? Well, let's get our original matrix out there. All right, so this will be our x coordinate. This will be our y coordinate. And there's S, there's U, and there's D. So if we put these into a matrix, we have negative 1, negative 1. We have 2, negative 5. And we have 3, 2. And you're going to translate it using the vector, which means a translation means you are adding values. So we're actually going to add the matrix 4 in the x to each coordinate and negative 5 in the y. And that's our translation vector. And that's an awful lot of verbiage just to be basically adding, okay? There's a lot of different ways you've heard that. And when you know, or hopefully you know, that when you add matrices, you're going to add each element that matches. Okay? They have to have the same dimension when you start. So our new S prime, U prime, D prime, there's our x coordinate and our y coordinate. Negative 1 plus 4 is 3. Negative 1 plus negative 5 is negative 6. 2 plus 4 is 6. Negative 5 plus negative 5 is negative 10. 3 plus 4 is 7. And 2 plus negative 5 is negative 3. So if we were to plot our new values, this works out to be the new S prime is the coordinate 3, negative 6. And the new U prime is 6, negative 10. And the new D prime is 7, negative 3. So if we plot those over here real quick, pick a different color. Well, I guess blue was a little bit different. So 3, negative 6. So 1, 2, 3. 1, 2, 3, 4, 5, 6. There's our S prime. 6, negative 10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's our U prime. And then finally 7. 1, 2, 3, 4, 5, 6, 7. Negative 3. 1, 2, 3. There's our D prime. You should never do this freehand. You should never do this freehand. I did something wrong, didn't I?
First point is you plotted 1, 1 instead of negative 1, negative 1.
Oh, you know what I did? I should have plotted over here. My original S should have been negative 1, negative 1. It should have been here. Thank you. That was the hidden voice of Karen Kelly. Which, big call out to Westlake. You need to call into Miss Kelly. All right, so there's our original. So now that completely messed up our original drawing, but watch. Now if we take that bug, right, along that vector, boom, there's the end of the vector. It's kind of hard for you to see, but it's right under there. It fit perfect, okay? So that kind of verified using motion that it worked too. So be very careful. Always double check. You have to make sure that original is right. Otherwise, it's like using the vector is kind of what they would do with an airplane. You start at a certain coordinate, and you follow a vector to get somewhere. It's not going to be good if you start at the wrong spot, right? You might not get to your destination. All right, well, I hope that helps you out. If you can call back with your name, I can't send you your certificate from Applebee's if you don't send me your name. So our time is up. In fact, I'm over a little bit. So we will see you next Wednesday. And don't forget to call, or here's the email again, real quick. Call or email. Hello, there it is. And I will see you next week. All right, thank you so much. Bye-bye.